asked to write each of the following quotients using a single base, do not simplify further. To determine each quotient, we will be using the quotient rule of exponents, which is x raised to the power of a divided by x raised to the power of b equals x raised to the power of a minus b. This rule is telling us to divide exponential terms with the same base, we subtract the exponents. However, it is important to recognize that when we find this difference, it's always the exponent of the numerator minus the exponent of the denominator. We will see why this rule makes sense after we take a look at number 1. Number 1, we have t to the 7th divided by t to the 3rd. Because we are dividing and the bases are the same, to determine the quotient, we subtract the exponents. So t to the 7th divided by t to the 3rd is equal to t raised to the power of 7 minus 3. 7 minus 3 is equal to 4. This quotient simplifies to t to the 4th. To understand why this rule makes sense, let's look at this quotient again and expand t to the 7th and expand t to the 3rd. So beginning with t to the 7th divided by t to the 3rd, we know t to the 7th is equal to 7 factors of t. T to the 3rd is equal to 3 factors of t. We're assuming t doesn't equal 0, and we know any value divided by itself is equal to 1. So t divided by t simplifies to 1 here, here, and here, leaving us with 4 factors of t, which equals t to the 4th. And this should make sense because notice how we have 4 more factors of t in the numerator than we have in the denominator, and therefore this does simplify to t to the 4th. But of course, it's much faster to just subtract the exponents, which we will do for the next 2 examples. So for number 2, we have the base of negative 2 raised to the 15th power divided by the base of negative 2 raised to the 12th power. Because we're dividing and the bases are the same, to determine the quotient, we subtract the exponents. This is equal to the base of negative 2 raised to the power of 15 minus 12. 15 minus 12 is equal to 3. This simplifies to the base of negative 2 raised to the 3rd power. Now we know this does equal 3 factors of negative 2, or negative 2 times negative 2 times negative 2, which equals negative 8. But we are going to leave this quotient in this form because it does say, write the quotients using a single base, do not simplify further. And now let's take a look at number 3. We have the base of 2 square root x raised to the 7th power divided by 2 square root x. So it's clear in the numerator the base is 2 square root x. In the denominator though, we do have 1 factor of 2 square root x, which means 2 square root x is the same as 2 square root x raised to the 1st power. In this form, because we're dividing and the bases are the same, we subtract the exponents. This quotient is equal to the base of 2 square root x raised to the power of 7 minus 1. 7 minus 1 is equal to 6. This is equal to the base of 2 square root x raised to the power of 6. And again, we will leave it in this form because it does say, write the quotient using a single base, do not simplify further. I hope you found this helpful.